Welcome to Vinex Studio. Let's start making games.
Hi and welcome. Today we are going to see how to use the Unity's inbuilt character controller to move your player. We'll also be seeing the advantages and disadvantages of using the inbuilt character controller. Now it's very easy to add the inbuilt character controller and you can have your character moving with just a few lines of code. It's very helpful for new developers, but it has its own limitations and it might not be suitable if you need custom movement for your character. So let's go ahead and see what Unity's inbuilt character controller has to offer. I have a slope and obstacle here, and I'm going to use the character controller to navigate this area. So let's go ahead and add our player first. So let me add a capsule, and this will be our player. I'm going to reset the position to 0, 0, and I want the height to be at 1. Okay, so yeah, so this will be my player. By default, Unity adds a capsule collider to the capsule game object. So we don't require a collider when we are using the inbuilt character controller because it has its own collider. So the first step will be to remove the capsule collider. So we'll remove that. Then click on add component and search for character controller and we'll add character controller. So if you zoom in on the capsule, you can see there's a collider on the capsule. So we have not added any collider component, but still there's a collider present. So this collider is different from the regular collider. Now you can adjust the size of the collider by adjusting the center, radius, and height properties of the character controller. Now before we go ahead and see how to move our character, there are some other parameters that we need to set, like the slope limit, step offset, the skin width. So the slope limit is basically the angle up to which the character will walk on a slope. If the slope is having an angle greater than that, it will not climb the slope. And for the step offset, if the height of the step is greater than the step offset, then the character will not climb on the step. Otherwise, it will step on it. The maximum step offset should be less than the height of the character. Skin width is like an extra layer around the character controller. So if you specify the skin width to 0.05, you can see that the position of the capsule is at 1, and if I play the game, it will lift the character controller by a small value which is equal to the skin width. So the skin width is 0.05, so now the Y value of the character controller is 1.05. So the skin is basically ignored if the collision is sideways, and if it is direct head-on, then the skin width is taken into account. Now, minimum move distance is the minimum distance that the character has to move for the character controller to basically change the position of the player. Say if you have small movement because of some other issues, some other external forces, say your character is moving at 0.01 units per second, so you want to ignore that movement, then you can set the movement distance greater than that value. So any value less than the minimum move distance is basically ignored. So now that all our properties are set, now it's time to move the character. So let's go ahead and add a script. So I'll call it character move. So I have an empty script here. So I'll add that. So let's go ahead and open the script. Now the first step will be to get the character controller. So we'll have a variable of type character controller. We'll call it CHA. And then I need a vector3, which will be my move speed. So in the start function, I'll get the character controller using get components character controller, and in the update, I'm going to set the move speed to new vector 3, and in the x-axis, I'm going to get the input dot get axis, and we'll say horizontal, and our y-axis will be 0 and z-axis will be input dot get axis vertical. Okay. So basically we're taking the keyboard input and assigning to the x and z axis. Now we'll just say character controller dot simple move, and we'll say move speed. Yeah, colon. So that's it. Our script is done. So if we go back to Unity, and let's play the game. So you can see that my character is moving now, and if I go, it's able to climb the slope also. And let's see if it is able to climb the cube. Step offset is 0.3, so let's stop the game and set the step offset to 1.5 and play the game again. So this time it should climb on the cube. Yeah, it does. So as you can see, Unity is taking care of all the slope and steps involved in the movement. So there is one problem with the simple move. Even if you set the Y value, it will not move in the Y direction. So let's say we set it to 2, and let's save the script, and let's go back to Unity. If you play the game, you can see that even if the Y value is set to 2, the player is still at a value 1. So basically simple move will ignore the Y value and it will not take it into consideration. If you want the player to use the Y value also, then you will have to use move in place of simple move. So let's say 0.01 F in Y, and let's say character controller dot move. The difference between move and simple move is simple move basically multiplies the vector value with time dot delta time, and move takes it as an absolute value. So if you use move directly, then the character will be moving much faster. So I'll be demonstrating that now. So now we're going to move the character using character controller dot move. So you can see that the character is flying up because we have set a Y value. So this time if I play the game and press the keyboard immediately, you can see how fast the character is moving. So we don't want that to happen. So in order to control the movement, you can just multiply the vector 3 with time dot delta time. Now since the character controller does not have a rigid body and a collider attached to it, so the regular collision detection will not work for character controller. So character controller has some collision flags that detects collision. So it will detect and tell you whether the collision has happened at the bottom part or on the sides or top part of the character controller. So we can just say if character controller dot collision flags equal to collision flags dot below, it should be equal to, and then we just say debug dot log, and we'll print character on ground. And similarly we'll say if character controller dot collision flags equal to collision flags dot sides, then we'll say debug dot log hit something, and we'll change the move to simple move. Okay, so let's go back to Unity and play the game. Let's open the console window. So it says the character is on ground. Okay, that's good. So now if we move our player and we hit something on the side, you can see hit something is getting displayed. Now there is one issue with collision detection when using character controller. is your character should be moving towards the direction of collision, otherwise the collision will not be detected. If the player is standing and something comes and hits the player, then the collision will not be detected. It has to be the player which goes and hits on the object. So this is one very big drawback of using the character controller. And if you want to know which character has actually hit it, then there is a function which is very similar to on collision enter, and it's called on controller collider hit, and it takes a variable which is also controller collider hit, and you can call it anything. This will get you the collider of the game object that the character controller has hit. So you can just say debug dot log, and you can say dot collider dot game object. Okay, so we'll remove the script. So if we play the game, you can see that the plain game object is returned because the character controller is on the ground as of now. So if we go ahead and climb the slope, so now we're getting cube 1. Now the next challenge is implementing jump using the character controller. As we discussed earlier, the simple move of the character controller does not take into account the Y axis. So we'll have to use the move function. And if you use the move function, it doesn't come back to the ground because move doesn't use gravity. So we'll have to create our own gravity. So let's go back to the script, and we'll need two floats. One is float gravity, and we'll set it to minus 9. And we'll need one more float, and we're going to call it jump speed, and we'll set it to 0.2f. Now in the y value we have to set it in a way that it uses the gravity. So this will be taking into account move speed dot y, then plus we'll say gravity into time dot delta time. Okay, so this will apply the gravity continuously on the player. So if there is no ground beneath it, it will fall. So we need to change the y value if a jump button is detected. So we'll say if input dot get key down, and we'll say key code dot, I think it's space. Yep. And you're going to say move speed dot y is equal to jump speed. Okay, so we are changing the y value to the jump speed, so it will start moving in the upward direction. And as soon as the spacebar is not detected, the gravity will again start working on it. So I think this should be enough, and we don't need this function. We can delete it off. So let's go back to Unity and see if our jump is working. So let's play the game. So since I'm using move, the character will move a lot faster. Oh, I forgot to change simple move to move. So let's go back, and we'll set this to character controller dot move. Okay. Since we're using move, we have to multiply the horizontal and vertical axis with time dot delta time. So I'll do that here too. I think since we're having time dot delta time everywhere, we can just multiply the whole vector with time dot delta time. So now if we play our game, the character seems to be moving okay. So if I press the space bar, it does jump, but the gravity seems to be very high. Okay, so let's go ahead and adjust the gravity value. So we'll not set it to 9.8, maybe we'll set it to something like, I'll set it to 0.2, and we'll see. So you can just play around these values and see which value is basically suitable for your game. Okay, so now my character jumps. So this is how you can use the character controller to move your character around and also detect collision and make the character jump. So there are some advantages and disadvantages of using the built-in character controller. For example, this is very easy to implement except for the jump part, and it takes care of the slope and step for you. If you have to program it for your custom character controller, then you will have to write a lot of code just to identify the slope and the step height. And using the inbuilt character controller, you can detect collisions without using rigid body. So that way you're not using any physics for collision detection. Now the disadvantages of character controller are like implementing jump is little difficult, and even though we say play with the values, it is not as natural as a physics jump. Then in the collision detection part, the character has to be moving in the direction of the collision, otherwise the collision is not detected, which may be an issue if your character is going to be hit with projectiles in your game. So it totally depends on your game whether you require that function or not. And one other major problem with this character controller is, I'll just show you in the scene view. So you can see that the collider is vertical, and if I rotate my character in the Z axis, the collider is still vertical. So the collider will not rotate no matter what the condition is. So this might also be problematic for some games. So if your character is going to rotate or is going to be a little slanting, then the inbuilt character controller won't be of much use to you. So that's it about the Unity's inbuilt character controller. If you have any other questions, you can leave them in the comment box below. Thank you and see you in the next tutorial.
Thanks for watching. Don't forget to like, subscribe and share.